All right, page 3. Use synthetic substitution to find the indicated function value. So for this one, we already know that x equals 2. So we're going to go ahead and put 2 in the little box. And let's count down. 4, 3, 2, 1, 0. Perfect, we've got them all. So we have a coefficient of a -7, a 3, a 128. Wow, that's interesting. 11, and a 6. Okay, and let's bring these guys down. So bring down a -7. -2 times 7 is -14. 3 minus 14 is -11. -11 times 2 is -22. 128 minus 22 is 106. That's a gross problem. 2 times 106 is 212. 212 plus 11 is 223. 223 times 2 is 446. 446 plus 6 is 452. So you guys, the answer is going to be whatever my remainder is, which is 452. All right, okay, let's look at number 13. So same idea here. We're going to plug in what our x value is, which is -3. Let's count down, make sure we've got everything. 3, 2, 1, 0. We sure do. Okay, so coefficients are -7, -3, +15, and 33 this time. So these numbers look a little bit nicer. Okay, so bringing this down, I have a -7 times -3 is 21. 21 minus 3 is 18. 18 times -3 is -54. 15 minus 54, if we do 54 minus 15, I think that's 39, is it not? Yeah, and it's going to be negative. And then -3 times 39. Hey, if you can't do it, work it out. -39 times, well, don't worry about the negative sign. -39 times 3. 9 times 3 is 27. Carry the 2. That's 9 plus 2 is 11. So this is 117. And then 117 plus 33. See, that's 150. So my answer is going to be 150. So hey, you guys, the test, like the numbers aren't super big, but if you're asked to multiply something like 39 times 3, you should be able to do that. Okay, so if you don't get that, please come in and we'll work on it. All right, find all the roots using synthetic division if -1 is a root. So if they tell you that -1 is a root, what does that mean? That means when you plug it in, you get remainder equal to 0. Okay, so let's see if that works. So I'm going to go ahead and plug that in. Put the -1 in there. Let's double check we make sure we have everything. 4, 3, 2, 1, 0. So we're good to go there. So we've got a leading coefficient of a 1, a 3, a -7, a -27, and a -18. And the remainder better be a big fat 0. If it's not, then I'm doing something wrong. So bring down the 1. -1 times 1 is -1. 3 minus 1 is 2. Times -1 is -2. That's a -9. 9, -27 plus 9 is -18. Times -1 is +18. And look at that, it equals 0. Okay, so what do we do now? So this is my remainder, my constant, my x squared, and my x cubed. So let's write out the polynomial that we have left over, which is x cubed plus 2x squared minus 9x minus 18 equals 0. And let's use some grouping here. So if I pull out an x squared, I'm left with an x plus 2. If I pull out a -9, I'm also left with an x plus 2. So I'm really left with an x squared minus 9 times x plus 2 equals 0. So it's going to give me x squared equals 9, which means that x equals plus or minus 3, and this guy gives me that x equals -2. So all the zeros here, all zeros, okay, or roots, same thing, are going to be x equals -2, x equals plus or minus 3, and x equals the original one, which is -1. All right, so remember, zeros and roots are the exact same thing, or solutions, sometimes they call them that. All right, let's try number 15. So this time they told us this 3i is a root, which means, remember, these guys come in pairs. So that means that -3i is a root also. All All right, and that means if they're telling me it's a root or a 0, that means when you plug it in synthetically, you should get that the remainder is 0. So let's see if that works. So let's plug in 3i. Let's make sure it works. 4, 3, 2, 1, 0. So we're good to go. Okay, coefficients are 2, -7, 14, -63, and -36. Okay, remember I just said the remainder should be 0, right? So let's go ahead and do this. So bring this down to 2 times 3i is 6i. -7 plus 6i is -7 plus 6i. And if I multiply that out, if I do 3i times -7 plus 6i, that's going to give me -21i. And then 3i times 6i is 18i squared, which is really -18. You guys remember I squared equals -1, right? So this one's going to be 21i minus 18. -21i minus 18. Now the only two that I can really combine are this 14 and this -8. So here I'm going to have -21i. 14 minus 8 is -4. Now let's do it again. So I need to do 3i times -21i minus 4. So that's going to be, this right here is -63i squared, which is positive 63. And then 3i times -4 is -12i. So I have a 63 minus 12i. Kind of nice because these canceled, so I'm just left with a -12i. And then here I have 3i times -12i, which is -36i squared, or just positive 36, which gives me that 0. Okay, now even though that was a little bit gross, doing it the second time is not that bad. So let's do this in a different color. So this time I'm going to plug in my other root, which is -3i. Okay, and I'm going to see, because I know it's a root, the remainder should be a 0. So let's see what we get. If I bring down the 2, -3i times 2 is -6i. These cancel, so I'm left with a -7. -3i times -7 is positive 21i. So these guys cancel out. I'm left with a -4. And then -3i times -4 is positive 12i. So again, the remainder is 0. Okay, so what do I have left? This is my remainder, constant x squared. So I have 2x squared minus 7x minus 4 equals 0. If I do a big star on that, I'm going to get, that's -8, -7, so that's -8 plus 1 gives me that -7, divide by the leading coefficient. So I'm going to have this equals -4. So this is going to be x minus 4 times, and then here's my other one, x plus 1/2 equals 0. Setting them both equal to 0 gives me that x equals 4 and x equals -1/2. So what are all of my zeros if I want to make a list? All zeros are going to be x equals 4, -1/2, positive 3i, and -3i. All right. Okay, number 16 and 17, these guys aren't bad. List all the possible rational roots. So this is the p's over q's. So your p is going to be your 10, your q is going to be the 2. So list all the numbers positive and negative that go into 10. So that'd be 1, 2, 5, and 10. And then all the numbers that go into positive 2, positive and negative, are 1 and 2. So your p's over q's, when I divide these all by 1, I'm going to get plus or minus 1, 2, 5, and 10. If I divide them all by 2, 1 divided by 2 is 1/2. 2 divided by 2 is 1. I already have that one. 5 over 2, and then 10 over 2 is 5. So this should be your list. All right, doing the same thing for number 17. The p is the 9. So I'm going to list all the numbers that go into 9, positive and negative 1, 3, 9. And then the q is the leading coefficient there, which is a -4. So all the numbers that go into -4 are positive and negative 1, 2, 4. Okay, p over q. So if I divide all the p's by 1, I'm going to get 1, 3, 9. Don't forget your positive and negative, 1, 3, 9. If I divide them all by 2, I'm going to get 1/2, 3/2, and 9/2. And if I divide them all by 4, I'm going to get 1/4, 3/4, and 9/4. Okay, and you guys remember, if you ever divide and get a fraction that reduces to something you already have, you do not have to list it twice. Okay, and then this last little one, number 18. Find a third degree polynomial with real coefficients of the zeros. Ooh, there's a typo. This should say find a fourth degree polynomial with real coefficients that has the zeros 4, negative 1, and I. Well, if I know that I is a 0, that means that negative I is a 0 also, right? So if I know that x equals 4, negative 1, I, and negative I, okay, let's go ahead and make these factors. So the 4 comes from x minus 4. The negative 1 comes from x plus 1. This I comes from x minus I, and this negative I comes from x plus I. Okay, so I'm going to multiply these guys together first. That's going to give me x squared, and that's 1x minus 4x is negative 3x minus 4. And then I'm going to go ahead and multiply these two guys. Okay, so that's going to give me, if I just do first and last, that's going to give me x squared minus I squared, which is just really plus 1. And if I FOIL this out, so I get x squared times x squared is x to the 4th, and then I have x squared times 1 is x squared, negative 3x times x squared is negative 3x cubed, then I have negative 3x times 1 is negative 3x, negative 4 times x squared is negative 4x squared, and negative 4 times 1 is negative 4. Rewriting this and combining some like terms, so I have x to the 4th, then I have minus 3x squared, 3x cubed, my bad. And then I have 1x squared minus 4x squared is negative 3x squared. And then I have the minus 3x, and then the minus 4 equals 0. Okay? And then you guys all going to do 19 and 20 on the next video.